Hey guys, I'm Ritwik and we're back with the Intro to Machine Learning series presented to you by ISTE. Today we'll be going ahead with Gaussian Bayes algorithm. So let's dive into it. Gaussian naive Bayes is a variant of naive Bayes that follows the Gaussian normal distribution and supports only continuous data. So naive Bayes are a group of supervised machine learning classification algorithms which work on the principle of Bayes theorem. It is a simple classification technique and has high functionality and is particularly used for cases where there is high dimensionality of the inputs. Even complex classification problems can be solved by implementing naive Bayes classifiers. Naive Bayes classifiers, as we spoke before, are based on Bayes theorem. So one assumption we make is that every feature is independent of each other. These classifiers assume that the value of a particular feature is independent of the value of any other feature. In a supervised learning situation, naive Bayes classifiers are trained very efficiently. They require a small training data set to estimate the parameters needed for the classification. So they have a simple design and can be implemented through wide range of varied real life situations. So we threw around the terminology called Bayes theorem a lot. Let's see what it actually is. Its Bayes theorem is a principle in probability that is used to calculate conditional probability. Those who are studying a mathematics course might already know this if probability is a part of your course. But yet let me explain the whole thing as to how it works. So the formula on which this operates on is probability of event A occurring provided that event B has occurred is equal to probability of A and B both occurring simultaneously divided by probability of B. So if you can imagine a Venn diagram, it is basically the probability of A and B occurring with respect to the sample size being reduced to only B. Okay, so the formula equates to probability of A times probability of event B occurring given A has occurred divided by probability of B. Okay, so let's move on to the next slide. Here we can understand better with an example. Imagine we have black balls and white balls. Okay, so we have two bags, and bag 1 contains 4 white balls and 6 black balls, and bag 2 contains 4 white balls and 3 black balls. One ball is drawn at random from one of these bags and is found to be black. Now you are asked to find the probability that the ball which was drawn was from bag 1. So they've given the condition that the ball which is drawn is of black color, and now we have to calculate the probability based on this condition that the ball drawn is from bag 1. Let's say probability of event E1 is the event of choosing bag 1 and E2 is the event of choosing bag 2, and A is the event of drawing a black card. Since there are two bags and both are identical bags from the outside, the probability of choosing any of these bags is equal 1 by 2. All right, P of E1 equal to P of E2 equal to 1 by 2. So inside probability of drawing a black ball, given that the bag you have chosen is bag 1, is basically the probability of drawing a black ball from bag 1. That is 6 black balls are present and 4 white balls are present. So 6 by total number of balls, which is 10. So 6 by 10, which is 3 by 5. And probability of choosing a black ball inside bag 2 is 3 by 3 plus 4, total number of balls. black balls by total number of balls, 3 by 7. Okay, so now we are asked to calculate probability of it being a black ball, probability of it being from bag 1 provided it is a black ball. Okay, so if it is a black ball, it's obviously a black ball either chosen from this from bag 1 or bag 2, right? So let's consider that a ball, so our sample here is, so instead of the sample being probability of any ball being chosen, our sample here becomes probability of a black ball being chosen. Okay, so let's consider the probability that a ball chosen is black and is from bag 1. So so that's a part of the denominator here. So since our sample becomes the denominator, and the specific case becomes a numerator here. Okay, so P of E1 into P of A given E1. Okay, so it becomes P of E1 is obviously 1 by 2. So it is picked from bag 1, and in bag 1 the probability of the ball being black is 3 by 5 as we have calculated here. So 1 by 2 into 3 by 5 plus now we have to calculate the probability that a random ball chosen is from bag 2 and it's a black ball in black 2. So first so it is probability of it being a black ball, a probability of it being chosen from bag 2 times the probability of choosing a black ball from bag 2 is 1 by 2 into 3 by 7 as we have calculated before. Now our specific case is that our condition, the condition in the conditional probability is that it's a black ball, and our specific case that it's a black ball from bag 1. So if it has to be a black ball from bag 1, it is 1 by 2 into 3 by 5. So our end result is 7 by 12. If you break down this formula, it actually comes down to our this very formula. So probability of E1 into probability of A given E1 divided by probability of A. Since the denominator is basically since our denominator defines the probability of a black ball being chosen either from bag 1 and bag 2, so we can say the denominator is P of A. So here we get the formula P of E1. So it again boils down to this very formula. So I just we just went through how it is derived. Now let's move on to the working of the actual algorithm. When working with continuous data, as we discussed before, an assumption taken is that these values are associated. These are continuous values associated with each class. Here in Gaussian Bayes, which is a subset of Navier Bayes, we work on a normal distribution. Okay, so the likelihood of a feature is assumed to be the formula is probability of x1 given y is 1 by root of 2 pi standard deviation of y of the feature y squared into e power minus z score z score squared by 2. Okay, let me repeat the formula in case of any confusion. 1 by 2 pi 1 by root of 2 pi into standard deviation of the feature squared into e power minus z score squared by 2. Let's I will explain what is z score as we come. Okay, so yeah, an approach to creating a simple model is to assume that data is described by Gaussian distribution. So in Gaussian distribution there exists no correlation between the features or the dimensions as we consider here. The model can be simply fit by mean and standard deviation within each label. So within each class, suppose we have class A, class B, class C, all we need is the mean and standard deviation to fit the model and obtain the results. as you can see, a Gaussian, this is how Gaussian normal distribution looks like. It is a bell curve. It sort of looks like a bell curve. So this point over here is the standard deviation and of class A, and this, I mean, this is for class B. So now we are presented in front of us. There is an example point which has the feature value, which has the dimension or the feature value x. Okay, now for x we have to calculate the probability that x belongs to class A and the probability that x belongs to class B. As you can see here, from previous trained from the query data, we trained the model to obtain this obtain these two curves. It is here this is just a representation. Okay, so this graph, the feature x is plotted on x-axis, and the probability which probability of it being from either class A or class B is shown varying according to the values of increasing values of x in the x-axis. Okay, so so right here, if we consider a random value of x which is presented in front of us by an example, the value of this feature specifically being x. Now if we draw a vertical line above, which are intercepting both these graphs, we can calculate the probability of this data point being from either class A and class B. Okay, right here, because the probability distribution has been plotted. So now comes the theory of z-scores. Okay, z-scores is basically a measure of z-score is a measure of how far from the mean the data point is. Okay, so the variation, it's basically a measure of how varied, how far from the mean our chosen data point is of that class. So in more technical terms, we can say how many standard deviation units above or below the population mean is this data point from. Okay, so here in the formula we put that we input the z-score. So this model right here basically predicts the probability of a data point being from all the classes which are present, the probability distribution can be summed up from this formula. For now that's it, and see you in the next module.